Hey everyone, thanks for your time. I'm back from the trip to Utah for the SLS Next Gen solid rocket motor test at Northrop Grumman's Promontory facility there, one of multiple, but that's the one where they produce and test these large solid motors. While we wait for some additional material/content from Northrop Grumman, it's still the end of the second quarter of 2025, calendar year 2025, so I'll summarize what's known in public about the current status for Artemis II, III, and IV. But let's actually start with Artemis V and beyond, at least the legacy versions, because the most recent news was about two milestone tests for the SLS program conducted in the past week or so. One of which, in an ominous sign, was conducted by NASA in secret. This quarter was an eventful quarter, with big changes proposed by the Trump administration, and then big changes to big relationships in the administration. They aren't as big as that, but we just had two significant SLS static fire ground tests occur. The hardware tested would be for program upgrades that wouldn't be phased in until after the White House wants those programs gone. That had a big effect on how one of those was shared with the public, or not. On Monday, June 23rd, NASA published a short, high-level announcement that an RS-25 engine test had taken place 3 days earlier on Friday, June 20th. This delayed, muted announcement was in sharp contrast to how NASA covered RS-25 engine tests for the past 10 years, where the public was notified before the test occurred, the test was live-streamed by the Stennis Space Center, and full footage of the test was published afterwards. As of recording this, over a week later, NASA has only released one still image of the test, one still of the VIPs who are still allowed to attend and view the test, but nothing else. In addition to conducting the test in secret, the announcement provided few details about the test or why this one was treated differently from the previous 10 years of operations. What changed in the last couple of months, obviously, was the plans that the executive branch has for those upgrades. They want them terminated since they don't want SLS flying after Artemis III. What NASA and prime contractor L3Harris tested was the first flight engine of the RS-25 production restart program, and this test was a major milestone. The new flight engine would serve as a backup unit for Artemis IV and a primary core stage engine for Artemis V. Both missions, again, that the White House wants to be terminated and rethought under a commercial transportation service. The silence from NASA on test day and the lack of information released afterwards is an abrupt change and ominous sign that they are going to hide that work from the public going forward. We'll see. As I've said more recently, as it becomes more obvious, the more secrecy there is from a public agency, the more we're going to have to talk about it, since they aren't showing or telling us what they're doing anymore. There's more to say about that secretly conducted RS-25 engine test in future videos. Less than a week after that secret test, Northrop Grumman fired their first full-scale demonstration motor using a clean sheet design that wouldn't fly until after the RS-25 upgrades, not until the 9th SLS launch, assuming there is one. But in contrast to the RS-25 test, the public and the media were invited to view and document the test, which was conducted at their Promontory facility north of Salt Lake City, Utah. The test broadcast was carried on a NASA live stream, albeit a low-resolution one. This was the first booster obsolescence and life extension demonstration motor. Northrop Grumman designed a new solid rocket motor that has nearly the same form and fit as the current SLS boosters, but uses a new design, new materials, and new production processes. The current SLS boosters were designed to be flown as the first stage of the Ares 1 constellation vehicle. These are designed specifically to integrate with the rest of the SLS Block 1B configuration with the core stage and exploration upper stage. In a briefing before the test, I asked Dave Reynolds, the manager of NASA's SLS Booster Element Office, and Mark Tobias, Northrop Grumman SLS Booster Chief Engineer, about the performance they were aiming for after this booster design has gone through the entire development process.
Yep, go ahead, Bob.
You mentioned the performance improvement. Just to clarify, the 5 metric tons or the performance improvement, would that be for co-manifested? That would be co-manifested performance?
The original intent was yes, was to accommodate co-manifested.
Okay, but I mean, you would be looking to get about 5 metric tons, or in the ballpark
Yep.
of above of co-manifest performance.
So very specifically, what we designed to was 5 metric tons on average above Block 1B performance.
Okay.
The test occurred around midday on Thursday, June 26th. The target for the mean bulk temperature of the propellant for this first test was 60 degrees Fahrenheit, or what's considered ambient temperature. They were expecting a peak thrust of 3.97 million pounds and an action time of 127 seconds. Ignition came at 12:25 p.m. local time, and the motor operation seemed to be normal until about 100 seconds into the burn, when something appeared to fail in the nozzle area. That was followed by 2 explosions, which destroyed most of the nozzle and probably other equipment in the aft skirt.
T plus 110 seconds.
Activate forward deluge.
Activated.
After the test, it appeared that almost everything in that area was missing except for the skirt itself. With the motor operating without a nozzle for several seconds after that, hot gas eroded the aft skirt, burning through it in several places. Looking back with the benefit of hindsight, in that pre-test briefing, Mr. Tobias had talked about the test objectives for the nozzle and some of the uncertainty going into this first full-scale test of the design.
This motor, we're pushing the environments inside this motor fairly significantly. It's a pretty powerful booster. And so our nozzle is designed to handle that, but there's some uncertainty in how well the ablative materials will perform under this environment. So that's a major test objective, is to evaluate how well they held up.
After the test on the NASA livestream, Mr. Reynolds also talked about pushing the margins on the motor design.
This test is a brand new booster from tip to tail. There are so many things that are different about this booster. It actually has very little relationship to the current boosters that are flying on the Artemis II mission that's coming up. And so we were expecting to learn a lot of things, and I guarantee that we're going to spend the next 6 months digging through all of that data and finding out what we need to do. Now, we push the margins on almost every material that we have, and that, I would suspect, is probably one of the first things that we are going to learn, is how close did we come to the edge of those margins. And if we did get too close to the edge that we're not comfortable, we've got other plans in place to move forward and build another motor that can teach us the things that we needed to learn from.
As he noted, they will be going through a long post-test analysis, looking at the data, looking at the hardware, and in some cases what's left of it, and looking at corrective actions and improvements. So it could be a while before we get a detailed post-test report, or at least some updates on what happened. But we'll be asking for that going forward. This demonstration motor was the first of 2 or 3 DM tests, followed by a critical design review, then 2 qualification motor tests, and then more work after that before a final evolved design could be certified with the SLS Block 2 vehicle configuration. Before the test, a 3rd demonstration motor was being held as an option, something we might guess now would be more likely. However, there are a lot of big picture questions about the future that would factor into that. As I said, the media was invited to document this test, and Jack Beyer with NASA Spaceflight got some amazing footage of the motor operation, including the anomaly, on one of the remote cameras he set up at the test stand. I'll provide a link to an NSF video with highlights of that if you haven't already seen it. Northrop Grumman has better and more comprehensive footage of the test, but we might have to wait a little bit to see just a little bit of that at some point. For now, we can watch Jack's video that's up on NSF's channel. The day before the test, Northrop Grumman also gave us a tour of parts of the promontory facility. We weren't allowed to record the tour, but a Northrop Grumman photographer took pictures throughout, and that will help illustrate some of the things we saw and heard. I'll go through the tour in more detail in a later video after we get that imagery. There were multiple highly visible Artemis II milestones during the second quarter of 2025, which I followed every week. That began with the more symbolic milestone when the mission and crew patch was publicly released in early April. Most of the milestones were with Artemis II launch processing and preparations. At the beginning of the quarter, the remaining major SLS elements were stacked on Mobile Launcher 1 in High Bay 3 of the Vehicle Assembly Building at the Kennedy Space Center in Florida. Following the lift and mate of the core stage to the boosters near the end of the first quarter in late March, the Launch Vehicle Stage Adapter, or LVSA, was lifted into place in mid-April, followed by the interim cryogenic propulsion stage in late April, early May. As Exploration Ground Systems lifted the elements into the VAB integration cell and bolted them together, they began parallel work to connect the systems of the rocket stages and the mobile launcher together, and then run through a detailed series of interface verification testing and systems functional tests. First, the SLS booster and stage systems need to be plugged into each other, and the mobile launcher umbilicals need to be plugged into the vehicle. And EGS integrated operations started with verifying the SLS boosters and core stage interfaces. Those are a part of the primary flight control system during the first 10 minutes or so of the flight. Later, the ICPS flight control system, which was originally developed for the United Launch Alliance Delta IV and Atlas V launchers, will be integrated with the ML and the ground launch processing and control systems running in the nearby Launch Control Center at Launch Complex 39. EGS is also beginning functional checkouts of the SLS propulsion, mechanical, and engine systems, called Program-Specific Engineering Tests, or PSETs in this context. That includes exercising the SLS command chain from the flight computers through the guidance, navigation, and control computers, and the specialized subsystem avionics. The RS-25 engines are a separately produced and managed element in the SLS program and have their own engine controller units. Those avionics will be commanded to run through pre-launch readiness checks to verify they are ready to support launch countdown and fueling, ignition preparation sequences, and then operation before, during, and after main stage. The SLS-only part of the integrated test and checkout campaign was expected to be completed by the end of this quarter, at the end of the summer, beginning of the fall. That was the last schedule update we got, which goes back to the end of last year, beginning of this one, which had Orion's pre-stacking launch processing completed by that same time frame, end of September, beginning of October. During the quarter, the Artemis II Orion spacecraft reached a major milestone, with prime contractor Lockheed Martin completing assembly and test at the end of April, early May, and handing it over to EGS spacecraft offline operations. Orion was moved from Lockheed's production facilities inside the Neil Armstrong Operations and Checkout Building to another building in the KSC industrial area, the Multi-Payload Processing Facility. The MPPF is where NASA loads and handles hazardous materials. For Orion, most of the flight commodities are loaded onboard storage tanks in the service module and crew module in the MPPF. I've been following progress of that work by EGS spacecraft offline operations as best as I can. As of the last status report, the large load of the hypergolic bipropellant in the service module propellant tanks was complete, and loading of the 4 consumable storage system gas tanks with oxygen in 3 of them and nitrogen in 1 of them was in progress. Looking ahead, if NASA is going to stay close to the goal of rolling the launch-ready vehicle out to Pad 39B by the end of the year, they need to reach the next major milestones by the end of the next quarter, the third quarter of 2025. Pre-stacking Orion preparations are the current critical path, and there is a month left to complete all the work in the MPPF by the end of July. As just noted, EGS completed the service module prop load, but still have to finish loading the consumables, thermal control loop fluids, and the crew module propellant system. After that work is complete, the flight crew will take part in crew equipment and launch and entry suit interface testing while the spacecraft remains in the MPPF. We'll be watching to see when that is complete, and the spacecraft is transported from there to the Launch Abort System facility, also in the KSC industrial area. EGS was bookkeeping 2 months to stack the Launch Abort System motors and tower on the crew module, check out the abort system interfaces to the spacecraft flight control systems, and encapsulate the crew module in its launch fairing, which is an element of the LAS. At the beginning of the year, they wanted to move to the LASF at the end of July, early August, and then from the LASF to the VAB by the end of September, early October. How close they can stay to those forecasts will say something about how close they are to launching in early 2026, or closer to the official launch target date of April 2026. In the VAB, EGS integrated operations was looking to complete the SLS-only part of the integrated test and checkout by the time that Orion shows up ready to be stacked. So the goal would be to have all the interface and functional checks of the SLS boosters, core stage, and ICPS systems with the EGS mobile launcher and ground launch processing systems done by the end of the quarter that is just about to begin. Once you get past Artemis II, as has been the case oftentimes for the last 10 years, things get a lot cloudier. For Artemis III, we are aware that the critical path work for the different programs continues, but we only have a few notes about progress during the quarter. The lack of status and updates is unfortunately normal. The most visible program is SpaceX's Starship, which is designing and building the lunar lander for Artemis III. They are focused on the foundational elements of the Starship system, which is where the visible activity is right now. The HLS lunar lander would build on top of those elements. Progress for Starship prototype development and test remained slow during the second quarter due to a continuing series of anomalies during incomplete flight tests. 2 flight tests were terminated early in the first quarter of the year before the ship completed its ascent burn. In this quarter, the ship for Flight Test 9 in late May made it a little farther, completing the ascent burn. However, the ship lost all attitude control within a short time after insertion and was unable to continue the test. SpaceX was preparing the next ship prototype and a previously flown booster for Flight Test 10 at the end of June when an anomaly during a static fire on the ground destroyed the ship prototype and significantly damaged that ground test site. It's still not clear how long it will be until the next flight test, or whether SpaceX will fly any more prototypes of this revision of the design, but most of the re-entry flight test objectives planned for Flight Test 7 back in January still haven't been attempted. So progress towards Artemis HLS milestones has, in some ways, been stalled throughout 2025, and it's possible that will continue to be on hold for a lot of the upcoming third quarter. Artemis III was delayed to mid-2027, not long before this new series of Starship delays. The other programs have had their own schedule challenges, but these delays on their own are likely to further delay the lunar landing mission. It's not so much a delay of a month here or a few weeks there, as stringing several of those delays together without other progress in parallel. This isn't as big of an issue for Starship as it is for Artemis. Starship's future is not as tied to Artemis as the future of Artemis is tied to when Starship and the other Artemis III programs are ready for the mission. Although Artemis III is literally scheduled 2 years from now, it is still far enough away that issues with one program schedule don't impact the work schedules for the others. For Orion and SLS for Artemis III, they are still working towards need dates that align with the current mid-2027 target launch date. We don't know what those need dates are exactly, and those aren't kept up to date in public that often. But production of the remaining incomplete elements would need to be nearing completion by this time next year. Those 2 pieces are the Orion spacecraft and the SLS core stage. For Orion, Lockheed Martin completed the initial power-on of the Artemis III crew module in late April, and they are targeting the IPO for the service module during this upcoming summer quarter. I recently got an update on the heat shield, which is processed separately from the crew module until they are mated later in the production flow. After the unexpected char loss seen on the Artemis I heat shield during re-entry, and the root cause corrective actions process that extended through most of 2024, NASA decided to scrap the AVCOAT blocks for the Artemis III heat shield. That decision continues to be overshadowed by the decision to fly the Artemis II heat shield as is, with a highly constrained re-entry trajectory that mostly eliminates the skip in the profile flown by Artemis I. In contrast to that, the Artemis III heat shield was shipped to the Marshall Space Flight Center last fall, where the AVCOAT material was machined off of the titanium heat shield carrier. The carrier for the Artemis IV heat shield was also delivered at the end of last year, and after trading options between the two, the Orion program decided to stay with the Artemis III carrier for that mission. That carrier was returned from Marshall to Florida and is now at Lockheed Martin's Star Center in Titusville. Lockheed has produced a new set of Avcoat blocks using a modified production process, and bonding those blocks to the carrier would be one of the next steps in that process. For SLS Core Stage 3, engine section integration and work at the Kennedy Space Center, and completing standalone work on the 2 propellant tanks at the Michoud Assembly Facility in New Orleans are the 2 critical paths for the element. For the latter, thermal protection system applications are nearing completion. During the quarter, prime contractor Boeing completed that work on the liquid hydrogen tank, with the automated application of the spray-on foam insulation completed in Building 131, Cell N at MAF. It was rolled out of that production cell in late April, and the liquid oxygen tank rolled in only a few days later. Internal and external equipment is now being installed in and on the LH2 tank, including the internal cryogenic liquid level sensor mast, and external brackets to hold propellant feed lines and pressurization lines. The only recent view of Core Stage 3 elements at MAF was in the background of this picture of interns in the final assembly area posted on social media. The LH2 tank is in the background, and part of the inner tank is visible in the upper right of the image. After the LOX tank completes its TPS applications, it will go through a similar set of production steps. However, the next big milestone will be the forward join between the inner tank, LOX tank, and forward skirt. Before that can happen, typically the LOX tank's internal sensor mast will be installed and the sump will be attached to the bottom of the tank. Last year, SLS had a goal of getting the top 4 elements of the stage all connected together and mostly integrated by the end of this summer, which would be by the end of the upcoming quarter. At that point, the 4/5, as it is also called, would be transported to KSC, where final assembly was recently moved. We'll see where they are at the end of the next quarter. Given the progress so far with the engine section and the 4/5, completion of the full stage in 2026 seems more realistic, and the question will be when in 2026. For the other 2 programs, the status of the lunar surface spacewalk suits that Axiom Space is developing isn't as clear. There wasn't a clear update in the NASA budget request documentation, as there often used to be. For exploration ground systems, they are only planning on turning around their software and hardware after the Artemis II launch, so we'll have a better idea about the scope of changes and updates needed after Artemis II. Looking ahead for Artemis III, we're waiting for a forward plan for Starship Flight Test 10. Questions include a new time frame for that flight test and whether or not it would be using version 2 or version 3 hardware. For the other programs, we're looking for updates to the integration and test milestones for the Orion spacecraft and SLS core stage elements. We should start to see those standalone elements for Artemis III begin to be mated into larger subassemblies in the second half of this year. Bigger picture, the questions for all the programs are the schedules for their need dates and interim milestones ahead of those. For Axiom Space, we'll be looking for any updates to the schedule for the AXEMU Spacesuit Critical Design Review. Looking beyond Artemis III, there are big questions that crystallized during the quarter. In many ways, the headlines from the political situation overshadowed a lot of work during the quarter. Political relationships changed during the quarter for who knows how long, and the budget request for the next fiscal year, which begins in October, made it clear that the White House wants to remake NASA. That includes Artemis. The major programs that are branded as Artemis are organized under the Exploration Systems Development Mission Directorate, and the budget request proposes eliminating everything except the commercial services for the lunar lander and the lunar surface spacewalk suits. Parts of that proposal would create conflicts with Congress for their race with China to the moon, and some members of the Senate have proposed continuing with the existing policy instead of starting over. That altogether increased the uncertainty about missions after Artemis III. Even though there's no guarantee that a lunar landing will be possible on Artemis III, the White House has already started implementing their proposal without waiting for approval or funding from Congress. There are now 2 concepts of operations for Artemis IV, V, and beyond. Even though the new proposal in the budget request is undefined, some parts of NASA are already acting as if it has been ratified. At the same time, the existing Artemis programs are continuing work on the current plans for Artemis IV and beyond. Even though, as I noted at the top, some parts of NASA are pretending that isn't happening, while the White House works to shut them down, with or without Congress. During this quarter, the relationship between former White House running mates, President Trump and Elon Musk, broke down. The Artemis part of the budget depends on and favors Musk's ambitions for beyond Earth exploration, which are focused on going directly to Mars and bypassing the Moon. The Trump and Musk breakup began to play out just hours after the full details of that budget were released, and that continues to play out a month later. Going forward, we're waiting to see if the Senate proposal to continue funding EGS, Gateway, Orion, and SLS for Artemis IV and V is passed there and in the House of Representatives. And if that happens, what comes next? At the same time, Congress could also mark up their drafts for next year's budget, and we'll see whether they stick with their existing plans or are persuaded to go with the White House ones. If Artemis IV and beyond are reassigned to future commercial transportation systems, those plans remain to be defined, and the current plans remain to be fully terminated, so I'll continue to watch both. We'll see if the White House releases a proposal, but they are already preparing to fire a large part of the NASA workforce, and that could have a significant effect on not just Artemis IV and beyond, but also the schedule and success of Artemis II and III. There were a lot more developments in public about the big picture for Artemis IV than about the actual work. Once the White House proposed that the existing plans go away, it became even more difficult to get updates or responses from those programs than it already was. There were few updates on Gateway progress during the quarter. The structure of the Habitation and Logistics Outpost was delivered to Northrop Grumman right at the beginning of the quarter, but we've heard nothing since then about integration work there or a time frame for completion of that work and delivery to the launch site in Florida. Near the end of the quarter, L3 Harris noted that the second of the Advanced Electric Propulsion System thrusters was delivered to NASA Glenn Research Center for acceptance testing prior to eventual installation on the power and propulsion element. Besides that, there was little news about Gateway logistics, the Dragon XL spacecraft that SpaceX was contracted by NASA to design, build, and fly, or the IHAB module that is being built for the Artemis IV mission itself. For different reasons, there was only one small update about the Starship HLS that would land the second Artemis crew on the Moon, which said that the critical design review for that was now expected in 2027. Otherwise, the focus of development is nearer to the present plans and milestones. The most visible activities in the quarter were continuing construction of Mobile Launcher 2, most prominently the rig and set of almost all the remaining pre-assembled, pre-outfitted umbilical tower modules. At the end of the quarter, the only remaining module left is the final one, Module 10. In another sign of the changing times, NASA and Bechtel have stopped publishing updates or imagery of those activities. However, they can be seen by media organizations at the KSC press site. During the quarter, we got some updates on welding and assembly of Exploration Upper Stage structural test article elements. Welding of the two propellant tanks is still in progress at the Marshall Space Flight Center and at Michoud Assembly Facility. Welding of the aft adapter was completed, and Boeing is beginning to set that and other pieces of the mid-body assembly into that tool at MAF. The forward adapter was the most recent element reported in the Vertical Assembly Center weld tool. For the core stage, integration of that engine section continues at Kennedy Space Center, and welding of the 4/5 elements is set to resume at MAF after EUS welding. As I noted at the top, we did see SLS booster flight hardware in production at Promontory this past week during a tour of the facility. Northrop Grumman is refurbishing the shuttle case and other solid rocket booster hardware, like the thrust vector control systems, into booster sets for the first 8 SLS launches. Casting of the propellant is complete for all 10 of the Artemis IV booster motor segments. However, there is still work to do on the 2 forward and 2 aft segments before they are ready to be shipped to Florida for a launch. We saw the two aft segments in the final assembly building at Promontory, building M397. In final assembly, the nozzle assembly is installed in the aft end of the aft segments. That doesn't include the exit cone, also known as the nozzle extension. That's not installed until after the booster elements arrive at Kennedy Space Center. The igniter is also installed at the top of the forward segments in final assembly. Right now, the aft segments are being prepared for nozzle installations, and the igniter installs into the forward segments would be later. But otherwise, the Artemis IV boosters are close to being ready for transportation to Florida. Instead, they will go into long-term storage at Promontory, where they will wait until stacking for that mission would be getting close. Similarly, news on the Artemis IV Orion build is more difficult now that updates for that mission are on hold. The one update we did get was from Airbus in early June. They reported installation of the Orion main engine into ESM-4, which indicates that integration of most of the major equipment was nearing completion. In the image they posted, we can see a pair of installed water tanks and one of the propellant tanks. The forward outlook for Artemis IV really hinges on political moves by Congress and the White House the rest of this year and maybe beyond. We will see if Congress decides to continue funding all the Artemis IV programs or not, but it may still be difficult to get updates if the White House and NASA leadership continue to pretend work on those programs doesn't exist.
Thanks as always for watching. Like and subscribe if you find these videos informative and want to find out what's going on with Artemis every week. As always, a big thanks to members of this YouTube channel who are helping to make it possible to keep doing these videos. I'm posting additional videos and more frequent updates for channel members if you're interested in joining. If you're willing to make a one-time donation to support what I do, I would really appreciate it. I put a link to my Buy Me a Coffee page in the description. Thanks again, and I'll see you next time.